Hello and welcome to today's webinar. The topic for today's webinar is Model and Design Reinforced Concrete Structures in Rfem 6 and Rstab 9. My name is Caroline Lessmann and I'll be your moderator today. I work here at Dlubal Software in the marketing department, so I'm responsible for the webinars and newsletters. And my colleagues will present the presentation and answer your questions, but they can introduce themselves.
Hello together, my name is Alexander Meyerhofer. I'm working for Dlubal for 15 years now. I'm responsible for the development of reinforced concrete structures and also for the development for nonlinear materials for the concrete calculations. A new part of the development is now the geotechnical analyze add-on, which is now brand new also in our Rfem 6.
Yeah, hello, my name is Adrian. I'm responsible for the customer support, especially regarding questions about reinforced concrete design. But I'm also responsible for the development and especially for testing the software, also mainly regarding reinforced concrete design. And in Rfem 6, I'm also responsible for the construction stages. And I'm answering your questions today.
Juliane, dein Mikrofon ist aus.
Thank you. Hello, my name is Juliane Stopper. I'm working in the Dlubal team for customer support and also for developers of the add-ons geotechnical analysis and reinforced concrete design. And today I'm here to also answer your questions in the chat. That's it from my side.
Okay, thank you for your introduction. Now we can switch off our webcam so everybody can see the full screen. Okay, and then I briefly want to show you how you can ask questions. So we always encourage everyone to ask questions throughout the presentation. On the right side of your screen, you have the control panel where you can ask your questions. And if by chance we don't get to all the questions, we'll certainly send you a question afterwards, an answer afterwards. And you also can watch the full webinar and send your questions to info@dlubal.com after the webinar, and there you also get an answer. And yeah, so that's now for the introduction, and I hand over to my colleague.
Okay. One question, is my monitor presented now? Is the right one with the content? Okay, perfect.
Everyone sees content.
So I will present today the modeling on the definition of some additional tools for the design of this reinforced concrete structures. I will especially take care about design of the slab over the ground floor. I will define some additional settings for the finite element mesh generation, take care about the singularities to avoid them and the joint of the column to the slab. Will go also in the design to the punching groove, which are especially on this nodes here where the column are placed. The reinforced concrete structures according to the Eurocode. I will design also a T-section here under the slab. Then I will evaluate the results. I will discuss the results. will show how we can work with the graphical displaying of the results, and also how we can print the results into the protocol in the printout report, and documentate our calculation. I will go now, or I go directly into the structure, in the Rfem structure. The structure was from the members and the slabs already defined. I only give you a short overview about the used objects. The basics of the reinforced concrete design, and also the design of members, the reinforcement, definition of members, also the design by using the member representatives. If we have more similar members, was shown in the first webinar for reinforced concrete structures, which was made or shown in November of last year. There are shown the basic steps, how you can define the properties and the settings, and my colleague Caroline will write the link into the chat where you can find this webinar. It is very good for the beginning. So therefore, I will go now today in the design, especially to things which wasn't shown in the first webinar. So the punching design was not so detailed, and also not the rib design. The structure is a concrete structure with C3037, and I use sections for the columns with 450 to 450 millimeters, and I have already prepared a section for the T section, which is named in our program as RIP. In the following webinar or the following description, I will always use the name RIP for the T section. I have thicknesses for the walls, 250 millimeters. The slab is 240 millimeters, and the slab on the grade is 300 millimeters. So this should be a small overview about the inputs which was done. The building is now have elastic springs, so elastic support, and this will have also influence later in the settings for the deflection design, which I will show you. At first, I want to deal with such nodes where we have the connection between the columns to the slab. And here we should make it in this way that here should be placed mesh refinements to have here better FE mesh. For this, I go to the data navigator, where by double click I can open a new nodal mesh refinement, give there my settings, which I have for radius 1 meter, and the inner target FE length is 15 centimeters. It comes from the dimension of the cross section of the columns. For the length arrangement, I use the combined approach, and now I will assign the nodes with two rectangulars where I want to have the refinement. And if we take it through in the isometric view, we will see I have it catched, and everywhere was now my mesh refinement. On these nodes, from the column and the slab, we have also singularities, and how we can deal in the concrete design with these singularities is described in a very good knowledge base article on our website, which I want to advise you. Caroline will also send the link to this article, technical article, in our chat, so you can find it very easy. And I will continue and select one approach, which is the use of the surface result adjustment. It means I will select or define the area which is exactly the width of the column, and set there the inner forces of the surface to 0. Surface result adjustment can be found on the special object. By double click, I can open the dialog, and now we can define a new rectangle result adjustment with the dimension of our columns. I want to have it on all 3 surfaces, and you see the number of my surfaces was so chosen that I know where is it placed. So 100 is the slab on grade, 200 the slab over the ground floor, and 300 is the slab over the first floor. If I press OK, I have already assigned the surfaces, and now I have to define the center of my adjustment. Here by copy, I can simply copy this adjustment and set only the new center of the result adjustments, and then I will have it in all areas. I make one new and want to define it also over the wall. The width is 25 centimeters, and I defined a little bit bigger area and defined it here because here is a wall. Define it also in this area. I made one failure. Now I forgot the adjustment type to define it. I want to set it to 0, and I want to set all inner forces to 0, and this should be done for all. To all defined adjustments. So I was one step too fast before. This should be done before I copy it, and then it is also always in the right setting. By OK, it will be placed. We can see it, and we can also work here by drag and drop. We copy it by drag and drop. If we press the Control key, you can put it by drag and drop, and it's very simple to work with it. So this is then for the connection of the columns to the slab. One additional settings for the slab is necessary. I want to have here hinges over the length of the supported line. The definition is very simple. We make double click on the surfaces, and the edit surface dialog will be open. Activate hinges, and in hinges I click to select lines, press Control, and then I have selected 3 lines where I want to have hinges, and the hinge type is as default already the moment hinge, and I will put it to all lines, the line hinges number 1. Okay, doke, it's ready now, and if we take a look to our refinement, it is everywhere placed, and also the adjustment. In the display navigator, we can deactivate the mesh refinements because I don't need it anymore for the work now, and the graphic is then more clear for the presentation. Display properties one. Okay, it's also here. Display properties are placed now under the results objects, and then it's also deactivated. As next step, I will define the rib for for the slab over the ground. For this, I will hide the first floor by selection, and now I have the first floor. By using new member, I can define now section rib by selection of the section number 2, which should be used for the web. The web should be 500 millimeter high. I can define now the rib from here to here, and also from here to here. Oh, something was wrong. Okay, I do it again. I know what was the topic. I will make the selection new and select only the slab which I want to show. So the new member is the same section, section number 2, and then from here to here. By escape, I come to another point. So if we take a look to the complete view, we see here in the first part, I took care about the rib. I go now in the rib section, and this is a very new feature that we can now also define more sections or segments during one length of the members. This is completely new developed. I use here the calculation of the width, integration width according to Eurocode 2, and the splitting of the segments can be done in 50% and 85% and also 100%. And we see now we have more different or more integration points. Here we have an inner support, and it means we have to consider also for the calculation of the integration with the length of the neighbored span length. So I have to define here 180, and I have now my different integration width. We have here also a new option that we can make here distribution, a linear distribution from the integration width, and now we have defined the rib for the design. For the second member, I use here the copy of object selections. It's a very nice tool. If I click here, we have here really copied all inputs. It's a rib, and only the thing which I have to change is now that the end field is related to the segment, and this is for the user-defined point 80. And then the inputs for the static analysis is ready. And now I do it again what I did before. And a very nice feature from Rfem 6 is now that we can show the rib section also in the graphic, and we see that the integration width is also shown here in our main graphic of Rfem. Okay, now I will select again my slab here, and will continue with the definition of the design properties. The design properties for the reinforced concrete calculation are activated by double click. I come into the surface dialog, and I continue with the concrete cover. the concrete exposure durability is defined by the exposure class, which is default to XC1. This is what I let. It's okay. The design direction of the reinforcement is the first direction goes in X. This is also default, which I will not change. And here is one important topic. In the surface, I need a surface reinforcement for the diameters that I will know the statical depth for the calculation. I just design a type of basic reinforcement. Which will be in both direction, the diameter 10 with a distance also 10 centimeters, and by pressing OK it will be then assigned to the surface. Here are listed design configuration, which I don't discuss today. This was in the first webinar very detailed. I will later take a look to the serviceability configuration. But here's one very important thing, which I mentioned before at the beginning. We have an elastic supported structure. Therefore, it is an advantage to relate the deflection to a also deformed slab or plane. And here I use the parallel moved slab as a reference plane for the deformation, and as reference length I will define it manually by 2 points and say my reference length for the maximum allowed deflection is from here to here. It's about 5.5 meters. By OK, I have defined all properties for the reinforcement design. We can also take a look to the graphic. If we go to the types of concrete, we see here we have surface reinforcement longitudinal, and if we activate it, we see that the reinforcement is defined in this area. Okay, I said that I will take care about the punching design of the nodes which are here. So it is like for all objects, we have to select it and go into the nodes or object dialog, edit nodes, and activate the design properties. Here it's only for now important that we have to check for design of the punching groove, and then we will have here also assigned the punching groove in the add-on concrete. I will go now to the definition of the ribs. Here we need also reinforcement. I want to design not two members. I want to design it with a set of members. So therefore, I select both by press Control key, and they create a new set of member. And here we have now the new set of member, and I can say now design properties for this set of member, and we see that there was now open all inputs for the design properties. It means the concrete cover is now shown, and here we have also the same durability which we have already used for the slab is XC1 and the shear reinforcement. I will change the distance to 50 centimeters, and if we take a look in another view, then we see here the cross sections or the variable cross section of the rib is already shown here, and also there are the reinforcement, and I will go to the longitudinal reinforcement. We see here the reinforcement which we have defined for the slab design or in the slab is here already placed. If we go more, we will see it. It is activated by this icon. If somebody don't want it, you can deactivate it or let it. I want it, so therefore I will let it here. But I will define now different distribution of the longitudinal reinforcement. I want to have it unsymmetrical here in the web. So therefore on the top side I will define here these three rebars with the diameter 20, but a lateral reinforcement also from 2 diameter 10. And on the bottom side, I want to have 4 diameter 20. And it will be directly updated here in the graphic. Here is also the 3D graphic of the reinforcement, which can be used for control of the inputs. Hopefully be shown. Here we see a small reinforcement drawing, also the used shear reinforcement, which can be activate or deactivate. It's nice for control and for printing. Okay, I can close it. Design configuration is the same like for surfaces in all parts. And now is one important tab. We have to define now the deflection properties or conditions. I want to check it only in the deflection in Z direction for the gravity loads, of course. And here is the point. My reference is then the deformed segment ends. This is now also the point which I mentioned. We have an elastic supported structure. So it means also the supported ends will be a little bit displaced Z, and this I don't want to have in the design check for the deflection. Important is that I generate on the ends or on the middle some design supports. We have here design support in Z directions, and our wall is 250 millimeters. It's a monolithic connections, and will be used for the walls on the end and the start. I directly copy it and use here also the width for the columns, which are inner supports, and here I have to deactivate inner supports and press OK, and then it will be placed directly at the beginning. I will change here the view to see it. Here we have the first one, and at the end it will be also placed, and with the 250 millimeters width, and in the center I will also use the design support, but it is now for the column and it's bigger. It's 450 millimeters. And we see here now for deflection we have here some lengths, 6 meters and 6 meters, and if we have some pre-camber we could define it here, but in this case I don't have it. But okay, we have now, we can confirm the inputs, and also we can check the member reinforcement and displace it, and see that everything is okay. Before I start with the calculation, I will make now new object selections. I have to be a little bit bigger. Create new object selection, and the advantage which will be done with this object selection will you see immediately after closing the dialog. This is my slab over ground floor, and I press OK. And now we have here in the object, in the guide objects, the object selections, and you see I have already done a little bit more, but the new one is the object selections number 200. And if I go now to the concrete add-on, I can use the object selections directly to define all objects which are there in the add-on. It is then replaced, and it will only shown object, and it is very good to organize the work. Before I will start to the concrete design, one topic where you can, or one hint where you can start or what you have to check in the basic settings. You have to activate the concrete add-on in the design add-ons, and in the standards you have to define the used standard for reinforced concrete design. Here I will use the Eurocode 2 with the original rules, so without national annexes. And if we have the loads, this is also one additional hint. I have defined a load case, self-weight and variable loads. We have to define the action category there. It's for the office. And in the base data, I have the combination group and the combination wizard defined. And in the design situation will be then automatically listed the serviceability and the ultimate limit state design situations. And here will be the list of all activated add-ons, design add-ons. Here we work only for the concrete design, so therefore I activated for the concrete design, and all load cases which are related to this design situation will be calculated. I can multi-select it, and what I have to do is that I have to select my combination wizard. The combination wizard here is in this way defined that we have to generate load combination, and the static analysis should be done by first order and geometrically linear. If we go then to the register load combination, this combinations was generated automatically and will be also used in the design of the reinforcement. Now I go back to the add-on concrete. We have here already designed the object selections. Material and sections are only list for control. Here are the ultimate configurations or settings which should be for the ultimate limit state. Here we have the serviceability state. I will take a look in the serviceability state configuration, and here we have the stress check which should be done, or the crack analysis should be done by finding automatically the limit value for the crack width. So it is here according to the exposure, defined exposure class. We have XT1, so therefore I expect in the calculation 0.4. With deflection calculation is here, we have this L, the reference length divided to 350. And here is the crack state detection for the serviceability. This I want to explain you a little bit more, because this is really new, which we have released 2 weeks ago, and therefore I'll take a little bit more time for it. The first one is the crack state calculation for each associated load. So each load case or load combination will be considered and calculated for himself. Crack state determination as envelope of all SLS design situation. It means the program check all load cases which are defined for serviceability and use then the correct element or the correct state, or this is the most safety or settings. Calculate the deflection only in a correct state independent of the load. It means there will be in all elements considered as it would be correct. I'll add it in the first setting and confirm it. Now I think we can start already the calculation of the statically analyzed. So firstly the mesh will be generated, and as next step the statically analyze is done. And you see here we can use now more cores of the PC. I have here 4 cores, and there will be 4 calculations parallel. It is very fast. Here in the concrete calculation will be done now a pre-calculation of the calculation of the stiffness, if there are cracks or not. Then will be done a second step of the find element calculation, and the deflection will be calculated, and in the last part of the concrete design will be then designed the cross sections, and the results will be then prepared for the display and in the table, and also for the graphic. Okay, so now we have here an overview what is fulfilled and what not. So we have very detailed tables. This is also the work with the tables is also shown in the first webinar. Today I want to work more with the graphics and use only now the settings for the member. Design ratios of the member we see here. It is everything clear here. I have 2% about the detailing of the spacing, and all design rules are okay. The design ratios, one thing more is here also differed or sorted by members, by surfaces, and by nodes. Design ratio for nodes is also new, and this is the design ratio for the punching proofs, and we see here it's not fulfilled. I will go now to the graphical results, and firstly we took a look to the results of the surface, and we have here the result values. I want to activate it as only extreme values, and here we have the panel. So here's a ratio of the defined reinforcement which we have, the ratio between the defined provided and the needed reinforcement. And here we see we have here in the red areas 2 less reinforcement defined. On the top side, here is also a punching problem. I would expect, of course, here more reinforcement for the punching design. If you take a look to the bottom reinforcement in the first direction, we have here everything in the green area. The maximum ratio is also on this small part, but the main area is under 1. And the second direction on the top, on the bottom reinforcement direction 2, is also okay. We have here a ratio from 93%. The punching proof of these nodes are now shown in the register in the tree for nodes. And if we activate here now the VID for nodes and for RDC, we see the corner columns can be designed, but the columns in the center are overloaded, and we need here more reinforcement. To work with it, I will go now to the reinforcement and take a look also to the nodes and show if we need a required punching force. And here we see for the required punching force we need 0, but we need then longitudinal reinforcement. In the configuration I said please calculate the required longitudinal reinforcement to avoid shear reinforcement, and we see if we would place here this 12 or 13 centimeters, everything would be nice. I will now define the missing reinforcement. For this, I will go to the global settings of my module add-on. I will deactivate the deletion of my add-on results if I change the reinforcement. And now I can work in the inputs. I deactivate also the mesh so that I have a nice view, and go now in the result navigator to my types for concrete. And for types for concrete, we have the surface reinforcement. With new surface reinforcement, I generate a new one, which is a free rectangle area. I assign it to my surface number 2, and the missing area here is for punching about 7.8, and I want to have it also only on top direction. And here is the area which I want to define. I activate my grid to have here a good coordinates. So I have a grid of 25 centimeters, and this area is already defined. I copy it like it was for the advantage result adjustments of the surfaces, and I can use here really the same concept. Now I want to do the input also on the other missing parts. For this, I copy the existing one and go in the result navigator, so we can really activate here our graphic, what we want for surfaces, and say the surfaces have a not covered reinforcement on the top side in this direction. And if we take a look here, I will define the same area over my supported line in the first direction, and in the second direction I will the same area, and take a look what is here. Here I need also some reinforcement about, and took it over this length. It was a little too small, so you can also make it again, and by pressing OK, it is then confirmed, and it is in the structure. For the surface, I can then take a look, where is my surface reinforcement. I go to the surface reinforcement and deactivate on surface, and we see what part of reinforcement is defined, and I can also check if the direction is right. Here I have defined one thing more too much, so this is only want to have only one direction, and it's the same was here. By OK, we will see I have only one direction. So easy is the definition of this additional reinforcement. Now I want to take care about the reinforcement in the rib. For this, I select it and change the view, and generate also a new object selections, which will be then the name should be the T section. Press OK. And here I work now with the design checks on members, and take a look how is my cross-section resistance. We see I'm under 1, so everything is nice. If I take a look to the shear reinforcement, the shear proof is also fulfilled, so I need no additional inputs. That is, the serviceability is done in this way that the stress of the steel is checked. We can take a look to the rack width, and the crack width is also fulfilled. And now we want to show you the newest release. We have here the additional details in the result navigator. This is since Monday in the Grandmaster, in the new version, which you can download from the extranet of Rfem 6, and you can activate here also then the direct value of the crack width. For example, we have here only 0.26, and it is also for deflection. The ratio is very small, and the existing deflection is now 0.6, and we see here it is related. Here is the end, it goes to 0, and this comes from the relation to the deformed structure. Okay, if we take a look to the required reinforcement, it is also here in the table. Required reinforcement of members, R is top, R is bottom, and we can take a look at it. You have here the graphic, and if we want to print it to the protocol, we have to generate a new protocol, and but what we have to consider is that the calculation must be, of course, done again. We change the reinforcement. For this, I go to the global settings, activate the deletion of the add-on results, and then it will be updated and deleted. And now I have to start the calculation of the concrete design add-ons new. You can do it also here in this icon and start only the calculation of the add-on. The statically analyzed results was not deleted because the reinforcement have no influence to it. Now it is only the calculation of the add-on concrete, which will be refreshed and done again. And as I said before, this is a two-step calculation. And in the last step, we have here also again a concrete calculation for preparation of the results and the graphic. So now we have the updated results. Design ratio by nodes, by members is okay. And then I will go to the printout report in the navigator and show you very simple to work with the printout report. If we generate a new printout report, I make it here for the concrete results or concrete design and assume that all other documentation of the statically analyzed will be done separately in another printout report. Today I want to show only the design or the reported of the concrete results. So types for members, types for surfaces we don't need, but types for concrete design is necessary for the durability clause and the surface reinforcement. And what I also need is here the concrete design, which we have to discuss maybe also what is necessary. We see here it is possible to show every tab which is also here in the add-on available. It can be printed, but I want to have here only the design ratio by set of members, and for nodes and for surfaces, the reinforcement for members should be also only shown by member set, because I design only the member set. The provided reinforcement by member set, the not covered reinforcement I will not show. For the reinforcement by nodes, I let it like it is, and the design overview will be deactivated. By save and show, it will be generated, and the result, the printout report is one of our new development in Rfem 6. It is completely new. It is a separate file, instance, which can be used here. It can be opened parallel to the Rfem calculation, and if we take a look to our results now, result members, then we go through the result of set of members. Here is one green one thing is the crack control, which is overloaded. This we can check later. Detailing is 1%. It's okay. So from my side, it's okay. For the design ratio of the nodes, is the punching design is also all ratios fulfilled. And if we go to the required reinforcement by member sets, we will see then the list of the required reinforcement. Here I want to show also the point how we can print the required reinforcement, because in my eyes a picture is better a diagram than many tables. Here we can use the printout report, the graphic, and here is the I want to use the current one. New is also the possibility to define an area in Rfem to print it to the graphic. Yeah. By 2 points. I will activate the grid. So we can move it, make it a little bit bigger. Okay. And this area will be then also saved and will be used for later. I make a little bit bigger high, and the panel should be outside of the graphic, that it will be not, yes. And by OK, it will be printed to the protocol. If you activate it, you can see it here and make it smaller. Everything is here. And by using also the inputs of the reinforcement, we can use now deactivate the design checks on the required reinforcement and activate our member reinforcement longitudinally and use the descriptions. And with description, we can print it directly into the protocol by the same functions. The same icon will be pressed, so the area is the same. I don't change anything, and with OK, it will be printed. Now I will take care about the slab. So for this, I will go to my view navigator, display view navigator, and this is the next advantage of the object selections. If you remember, I have here the slab over the ground floor, and if we take a look to the Z direction, now it's everything activated, what I have selected before. And I can continue with my presentation of the results for the slab. Firstly, I deactivate my member reinforcement, and in the result navigator for the design checks of the surfaces, I go to the ratio of my longitudinal reinforcement on the top side. It is okay. The bottom was also okay. We take a look to the displacement. So this is a ratio like it is for members, and here is also the deflection. Important is for me now the punching proof, because this was not fulfilled before. We see it is now under smaller one, the ratio. It's perfect. And we can print now also a documentation of our results. I want to use now a bigger paper like it was done in the documentation. The first printout report, this is the format A4. I want to use now a bigger for the plots. Make a new one, new printout report, and say this is only my annex for plots. And for this, I deactivate all settings here and generate a new pages format. For this, I have to select a printer, which is possible to print bigger pages. So here it's my printer, which can print A3, but you need 7 millimeters on the bottom side distance, and I don't need some cover page. And with OK, it is saved, and save and show. I will get a new protocol, which is also showed then here, but it's empty until now, because I printed no reinforcement or no result there. I want to use now again the same one and print here then the surface. You see the last view is saved. I want to have a new one. I want to use it in Z, define it in the new area. So from here to here with OK, and with the multi-print, like I did it before, I can go to, or I can print all result diagrams which are necessary. Model it's not necessary, load cases here not, and in the add-on. And now you see this navigator is really the same navigator like it is here in the result navigator in the main program, and we can really print all results which we want. So here I print first the ratio between the provided and the required reinforcement, then the crack width calculation with top and bottom crack width, then also deflection design check with the UZ graphic. Detailing I don't show. I will also show me the nodes, the punching nodes, and here is the used shear force, the punching force, which is set in the calculation for RIDC. This is a very nice graphic. On each node we see then the value which was assigned in the calculation. Required reinforcement, of course, I want to have it also shown my required reinforcement and also my provided reinforcement. For surfaces and for nodes, I need the required reinforcement on the top side, which must be placed for avoiding the punching reinforcement and to fulfill the punching proof without shear reinforcement now. It is now started to generate. I have selected, of course, many graphics. It is started now to generate it in the here in Rfem, and then we will see it step by step in here in our printout report. Oh, this was my failure in the presentation. I selected the wrong one, so let us take a look here. The principle was the same. Let us discuss the result. It's now in the printout report number 1. Here we see the reinforcement. Everything is fulfilled. Also the ratio of the top reinforcement, the bottom reinforcement, it's okay. Here we have the crack width and the ratio of the deflection, and here also the crack width on the top side and the crack width on the bottom side. Okay, this is then the design of this slab, and we are ready with the design of the member of the T section, and also for the punching nodes. And I want to show you also the punching design of the foundation slab, where it is a special case. Here we have to have, here we need an integration of the critical parameter, where is the critical one. It's not 2D, it's iterative. So, and also to consider the soil stress under the ground slab. And this will be done now automatically. I do it in the same way that I select only now our slab, take a view in the Z direction, and the same what I did before in the presentation. I have to go to the node and say it's my punching design. Of course, I have new properties. Now I will be deleted the results. Further, I have to define the reinforcement in the slab that the punching proof can be done. This is very simple in the basic reinforcement. I use here then also the number 100, which I said before. This will be my slab over the ground. Great. And then we can start the calculation of these points if we remember. So I will, if we remember, we have here different types of the punching design. We have here a wall end at the border of the edge of a slab. We have here a corner column. We have here column at the edge, and we have here wall corner in the center of a slab. And here we have an inner column in the center of a slab. And this will be done automatically in the design. I will go to my concrete design. This is now only for presentation, how the iteration will work. I will not, so for selection, go the same way like before. Say, please design this node for the punching design. Okay. Member sets I don't want, and press OK. And now I will calculate the punching proof for this node on the foundation slab. And we see, I will go to other view, Z direction, it's better. And we see that the wall end is found, the property or the geometry is founded automatically. It's a wall end. Here we have the columns, and here we have a corner. We see also the result of the iteration of finding the critical section. Here it's a very small distance, and here we go until 2D. This means now that we can, the reinforcement is not enough, like I discussed before. And if we take a look to the required reinforcement of the punching node, we will see if we would need a punching reinforcement or if it could be done by some additional reinforcement. We need no punching reinforcement. We can use it and add punching additional longitudinal reinforcement. So also the punching design for a foundation slab is now implemented and can be very simply used in your daily work in the design of concrete structures. Okay, this is an additional topic or feature which I want to show at the end of my presentation. I will then finish and close my presentation with the picture of the punching design of the soil slab. Thank you for your attention.
Thank you, Alexander, for your presentation. Then I switch over to my screen again. And I briefly show you our website, dlubal.com. Here on top of the website, you find the free full trial version for Rfem 6 and Rstab 9, as well as R section 1 and Orbit 2. And Rfem 6 and Rstab 9 includes all the add-ons for the full 90 days. And here under news and events, webinars, you find all the previous webinars and all the upcoming webinars. And you also find here, the webinar from today, where I will upload the recorded webinar the next days. And when you scroll down, you find also the presentation slides as well as the model here. And yeah, so when you now leave the webinar, there is a survey. So it'd be nice if you shortly take the time to answer the questions. It's quite important for our quality management. And for your information, the worst score is 1 and the best score is 5. And then thank you for your attention. Thanks to my colleagues for the presentation and answering questions. Have a nice day. Goodbye and hopefully see you next time.